Before we start the video, let me give you a brief introduction about myself. I'm Chandresh Mahajan, who is founder and chief educator at Exergic, which is India's most trusted and comprehensive institute for online gate preparation. I got an All India rank 37 from Gate Mechanical Engineering, and I am an ex Indian Oil officer, having 6+ years of teaching experience as of now. To know more about our GATE courses, you can contact us on these details. Also, you can download Exergic GATE preparation app from Google Play Store. The link is available in the description of video. So the question that we are going to solve now is fundamentally a different question than the previous questions or the previous problems that we have solved. Let us first go through the problem first, and then I will explain you how this is different and how to solve this. The question says that a 750 Newton crate rests on a 500 Newton cart. Some basic terminologies should be known to you. Some common terminologies like crate. Crate is, a container, open container in which you can stack things like the cold drinks. They are stacked in crate, plastic crate. I think you would have seen it, right? So these basic terminologies should be known to you. So 750 Newton crate rests on a 500 Newton cart. Cart means something, a small, simple vehicle which has wheels which can be moved, right? So this is clearly shown in the diagram that there is a box shown of 750 Newton here, resting on a 500 Newton cart. The coefficient of friction between crate and cart, means on this surface, is 0.3, and between cart and the road is 0.2. Okay, these are the two values of coefficient of friction. If the cart is to be pulled, not crate. The force which is being applied is specifically acting on the cart. So if cart is to be pulled by a force P such that crate does not slip, you are applying a force on the cart and you have to make sure that this crate does not slip. Then determine the maximum allowable magnitude of P in Newton. Did you get the question? That a force P is being applied on the cart. When you will keep on applying and keep on increasing the force P, a time will come when 500 Newton cart will have a strong tendency to move in this direction, and 750 Newton will start slipping backwards because the force is not being applied on 750 Newton directly. It is being applied on 500 Newton cart. And then as a result of friction, there is a friction between these two surfaces, right? The friction is holding 750 Newton crate with this cart. So when this force being applied will be high enough that the friction cannot hold 750 Newton, then 750 Newton crate, then this crate will start slipping backwards. That point you have to tell when it will just start slipping backwards. At that time, what should be the value of P, or in other terms, the maximum allowable magnitude of P, such that the crate does not slip. It is similar in terminology to the one of the previous questions that we have solved. If I show the force P on number line, force P I am showing from 0 to infinity. From 0 to P in this region, the force is very small such that no slipping is happening. There is no slip happening. But as you keep on increasing the value of P, a point will reach after which it will start slipping. If you apply a very high force P, 500 Newton cart will have a high tendency to move here, which will slip 750 Newton cart in the opposite direction, right? So as P keeps on increasing, a time comes when it will start slipping. You have to tell the maximum value of P, means this range we are considering, such that crate does not slip. Same thing can be asked in a different way, that what will be the minimum value of force P. Minimum value, when we say, then we are talking about this range. What will be the minimum value of force P which can cause the slipping? You got the difference? I have already explained this once in one of the previous questions. So that value of P you have to tell. Now, how this question is fundamentally different than the previous questions, let me tell you. The previous questions that we discussed, in those questions, the body or multiple bodies were just moving, were just about to start, right? There was not a definite acceleration happening of all the bodies. Whatever case we considered, if even one body was moving, other body was not moving. We have not considered any example like this where both the bodies are moving, and we are not talking about just start, we are talking about proper motion of both the bodies. How? Let me tell you. When force P is 0, then definitely everything is going to be stacked up, there is no slipping. But when you start applying the force P, what will happen? Force P will slightly be opposed by the different frictions acting. But a time will come when, as a result of force P, the cart and the crate on the cart will start moving. Right or not? It is saying that crate does not slip, and slipping can be prevented even when both of them are moving. You would have seen such cases, I am very sure. You can consider your own case. Suppose you are sitting, you are standing in a bus. Suppose this is the bus and this is you who is standing. If the car or the bus is moving very slowly, in that case the friction between your sole, between your shoes and the floor of the bus is strong enough to hold you with the bus. But when this force is going to be very high, when this acceleration will be very high, there are chances that you may slip backward, right? So this situation, when the cart is moving and the crate is also moving, or the bus is moving and the luggage in the bus is also moving without slipping, is very much possible even when the force is being applied, even when they are moving. So this case is different than the previous case when the bodies were just starting the motion. Here body has not just started the motion, body is properly moving with a definite acceleration. And now you have to tell that what should be the value of P to avoid the slipping of this crate on this cart. So this is how fundamentally this question is different than the previous one. We directly applied the static equilibrium equation in the previous cases. It will be slightly different here, not totally, slightly different here, because there will be acceleration also coming in this case. Now, what we need to do, let us start from this particular block, the crate about which we are talking about, that it should not slip. Tell me, what is going to prevent the slipping? Let us talk conceptually right now. What is going to prevent the slipping of this particular crate? The crate wants to stay in its own position. If there was no friction, if there was zero friction on the surface, this force P will smoothly move the cart. The crate is not going to move. Crate will stay here only. Crate will slip and fall down as 500 Newton cart moves out. But friction between them is making sure that they are attached to each other. This 500 Newton cart is attached with this crate, or the crate is attached with this cart, right? So friction is making sure that this also moves. Friction has a grip over this 750 Newton crate. So if I draw the free body diagram of 750 Newton crate, this is the crate, 750 Newton weight. If I draw its free body diagram, there is going to be a friction force acting in the forward direction. Why forward? Why not backward? Because friction is the force which is trying to grab it, which is trying to hold it. Assume you in place of this 700 Newton crate and you are standing on the bus or any cart. If that cart is moving, then the friction is being applied by the cart on the sole of your shoes, and that grip is pushing it forward, and that is why you are getting pushed forward. So friction is making sure that you move ahead. So friction is acting in the further direction. Let us call this body as A and this body as B. So FA, friction acting on A, is pushing it further. What is the other force acting? Which is weight. Weight is acting in the downward direction. This is weight, 750 Newton. Normal reaction will be in the upward direction without any doubt. So just a second. Normal force will be in the upward direction, NA. Is there any backward force acting right now? No. But this system, this body A, is having an acceleration of A in the further direction, in the forward direction. As I told you, this case is not the case when 750 Newton crate just starts. We are not talking about that case. We know that 500 Newton cart is moving. It is gripping 750 Newton crate, which is also moving. You have to tell that point when it starts to slip backward. That point you have to tell. Are you getting it? So acceleration is existing if I talk about any general case right now. Okay. If I want to write this equation, the equation of static equilibrium or equation of equilibrium for this particular body, what can I write? Along the vertical direction, I can write that NA is equal to 750 Newton, or NA is equal to weight of A, which is 750 Newton. I have applied along y direction, and along x I can see that this friction force is causing an acceleration of A. So force is equal to mass multiplied by acceleration, Newton's second law of motion. So friction at A is equal to mass of A. Mass of A will be weight of A divided by acceleration due to gravity. This is mass of A, because mass is not given, weight is given to you, multiplied by its acceleration A. This is the expression that we have, right? In this expression, let us put different values if we know them. WA is 750. G, when nothing is said, you have to take it as 9.81. Acceleration, we don't know yet. What is the value of friction acting on A? It is mu multiplied by normal reaction, right? Mu is given as 0.3 between the crate and the cart. So mu value you will put, NA is equal to 750 you will put. This value you know, A you can calculate, right? But this is the normal way of solving the question. But if we make the question slightly complicated, then this question can get slightly more conceptual. Suppose I gave you two different values of coefficient of friction. I gave you that the coefficient of friction between the crate and the cart, the static coefficient of static friction, is 0.3, and coefficient of kinetic friction between crate and cart is 0. Let's say 4 or 0.2. So out of these two values, which one will you put here? That you tell me. Pause the video and think about it. You have two different values of coefficient of friction for this surface, both static and kinetic. Which one will you pick? The higher one, the lower one, the static or the kinetic? Come to the basics that I told you, that whenever you have a body on which you are applying a force, directly or indirectly, somehow the force is being applied. Maybe its own weight, maybe it is on an inclined plane and a component of its own weight is acting, right? So in such a case, if you apply a force and you see no motion, you applied a force but the body is not moving. When is that possible? When the force that you are applying is totally balanced by the friction. In that case, net force is 0, acceleration will be 0, no change in the velocity, body will stay at rest. This friction, which can oppose the applied force such that the block does not even start the motion, that is static friction, right? And the maximum value of that friction you can calculate by using mu SR or mu S normal reaction. This value tells you that how much maximum static friction can be offered by this surface, or in other words, maximum force that it can oppose in order to stay at rest, in order to avoid movement, in order to avoid slipping. That is told by mu Sn. So whenever you have to tell the maximum value of friction that can be opposed without motion, definitely it is going to be static. So even if question gave you two values of coefficient of friction, you have to choose the static one here. Okay, so here you have been given only one value of friction, so you can simply use that here. The value of mu, just a second, the value of mu is 0.3, normal reaction is 750, so this is going to be 250, right? And upon solving, acceleration will come out to be 2.943 meter per second square. This acceleration is the acceleration of the crate. Now you may think that what is the point of doing this, sir? Why are we calculating the acceleration of A? Look, this is, as I told you, fundamentally a different question than the previous ones. In this case, not only the 500 Newton and 700 Newton bodies are moving, but they are moving like a single body, like a single whole body they are moving. That is what question is telling you. That what should be the force P, maximum force P, such that the crate A does not slip back, means it stays together with B, it sticks to B, it holds on to B, just like a single body, just like it is a part of B. That is what question is directly asking you. So if the acceleration of this part is A, the acceleration of lower part or whole body, both of them, is also going to be A. So we have not only calculated the acceleration of the upper crate, but we have also calculated the acceleration of the lower cart, because both of them are moving like a single body, because A does not have to slip. Got it? So that acceleration we have calculated, and this will help us in analyzing this free body diagram of second body as well. Now let us draw, and there's one very interesting thing to tell here, but I will cover that later on. Let me first tell you the normal way of solving this question, and then I will tell you an interesting thing about this question. So a force is acting on this, on the left side. Force is P. Its weight, as we know, is 500 Newton. There is friction also present between the cart and the surface that will try to oppose the force, oppose the motion. So it will be acting in the backward direction. Friction at B from the bottom. Similarly, A is also present on the top. Since A experienced a normal reaction from B, B will also experience a normal reaction, same in magnitude, opposite in direction, right? Newton's third law of motion. So it will be experiencing a normal reaction A in the downward direction. Or for this case, you can clearly see that it is equal to weight of A. So you can also say that directly weight of A is acting on B. All right. But it is always best to use normal reaction and not the weight directly, because if you recall, in one of the previous examples there was a string attached also, right? There was a string also attached, and that string was having a component in the vertical direction. So in that case, NA was not only related to W, but NA was also related to a component of T. That is why do not do this silly mistake. Some students do it, that they directly think that okay, A is above B, so weight will be acting it down. No, there can be some other connections also present which can affect the normal reaction. So always go with normal reaction. It is acting in the downward direction. Also, B is exerting, means A and B are having a friction in between them at the surface that we have already considered here. So if friction between A and B is acting in this direction on A, then it will act in this direction on B. Newton's third law. So friction force, the reaction of friction force on A will be in this direction. Or in other words also, suppose you are B, suppose you are body B, and there is something which is kept on you, and we are trying to pull you in some direction. Obviously that body on you will try to apply some friction force on you, will try to apply a force in the backward direction on you. It is the friction of A on B simply. So this is FA, right, acting in this direction again. Now comes the interesting part. The interesting part is that FA is equal to mu A, means this value of mu, multiplied by NA, right or not? And FB is equal to mu B multiplied by NB. Now in this case, what is going to be NB? That is interesting. Look, NB you have to assume in the upward direction. Normal reaction at B will be acting in the upward direction without any doubt. Now you apply summation of forces in this and this direction as 0. Later on I will tell you why this FB was interesting. Right now you will not understand it. I will tell you later on. Okay. So let us try to apply summation of forces along vertical direction as 0. NB is acting in the upward direction. NA, which is 750 Newton, is acting in the downward direction, plus 500 Newton. Its weight is also acting in the downward direction. So in totality, it is 1250 Newton of reaction NB, right? Now let us apply it in the horizontal direction. In the horizontal direction, we know there is an acceleration in this direction. So what do we have to write? P minus FA minus FB. This tells the net force in this direction will be equal to mass of the body multiplied by acceleration in this direction, which is same as the acceleration for the crate, because both of them are moving like a single body. MB can be written as weight divided by G. So let us do that right away. Weight of B means weight of this cart is given to you as 500 Newton. So 500 divided by 9.81 multiplied by A. The value of A we already calculated as 2.943. Now look at this expression. FA is equal to mu A multiplied by NA. We have already done that. Mu A multiplied by NA. So value of FA we also know. How much will be the value of FB? Mu B multiplied by NB. NB we have calculated here. So basically everything is known. P is not known. Right? Let us put all the values and find the value of P. So FA is equal to mu A multiplied by NA. This will come out to be 225. Minus FB is mu B, which is 0.2, multiplied by NB, which is 1250. Upon multiplication, you will get it as 250 Newton. Alright. So FB is equal to 250 Newton here. This is equal to 500 divided by 9.81 multiplied by 2.943. You got it? P is the only unknown. Solve it and get the value of P. You will get the value of P as 625 Newton. So this is how this question was to be solved. In this question, there is acceleration involved. Bodies are not just starting the motion. They are moving, but they are moving in such a way that this body, this crate, has to just prevent itself from slipping. And this will be the case when it is acted upon by the maximum or the limiting value of static friction. This is the funda here that tells you that this crate here is in the limiting state of maximum force that can hold it in this direction. Any further increase in the value of P will increase this acceleration, and if this acceleration is increased, then the cart will start moving in this direction, but this block cannot have that value of acceleration. This value of acceleration that you are calculating from this formula, what is it telling you? It is telling you that A acceleration which you are calculating using the maximum value of friction is that acceleration which the crate can withstand. If you apply any acceleration, let me clean it up a little bit. If you apply any acceleration higher than this one which you are calculating, then this crate will not be able to move further, because the force acting right now is the maximum value of limiting friction, static friction, mu r. Mu static, you cannot have a higher friction than this one, mu Sn. This is the highest possible friction or highest possible gripping force that can be applied. That is why if this is highest, this is also going to be highest, because this is a constant. So the value of maximum static friction is going to be the value of maximum acceleration that it can withstand without slipping. And using that acceleration also, we have calculated the value of P. You got the point. If you increase P, the actual acceleration of this lower cart will increase, and upper crate cannot sustain that value of acceleration. It will start slipping backwards. This is the funda of this question, right? And now let me tell you one more way of solving it, or rather the confusion that some of the aspirants have. Let me clear that first. But remember, the answer was 625 Newton. And now I am not going to use this free body diagram. I am going to use a different free body diagram. Let me tell you that. Look, in the questions before this question, whenever we were having more than two bodies, either in the two bodies they were moving in the different direction, or when they were moving in the same direction, they were not moving with the same at the same time with the same acceleration. One was starting to move, other was not starting to move at that point, right? They were not moving as a single body. But in this case, both of them are going to move as a single body. Actually, only that case we have to consider, that the crate does not slip. Crate stays together with the cart. They move as a single body. That is what question is telling you. In the first case, even though they were not moving relative to each other, but this was trying to move in some other direction when there was a pulley, and this was trying to move in some other direction. They were not moving as a single body, right? But in this case, they are moving as a single body. So what you can do, you can draw their free body diagram by considering them to be the same body. And in that case, 750 plus 500, a total downward force of 1250 Newton is going to act. There will be a normal reaction. This is the value of force. And since we are considering them together, their internal friction which acted in opposite direction in cancelling, we will not consider. We will just consider this friction between the lower surface of the cart and the floor, which is going to act in the backward direction. Pause the video, try to solve it. So this is the friction force acting on the surface, on the bottom surface of B, right? Now applying the equilibrium of forces along y and then along x direction. Along y, it will give you n is equal to 1250 Newton. Along x direction, if you apply, do not forget that it has an acceleration a in the towards the left direction. So applying the equilibrium of forces along x direction, it will give you P minus FB is equal to its mass multiplied by acceleration. But now the mass is the combined mass of 700 and 500 Newton. Combined mass is 1250 divided by 9.81 multiplied by the acceleration 2.943. And now in this expression, FB, if we know, then we can easily find out the required value of P. And obviously we can find out the value of FB. FB is equal to the friction between this bottom surface of B and the floor. How much is the friction? It is coefficient of friction mu, which is 0.2 here, multiplied by N, which is 1250, right? We calculated it, 1250. And this will come out to be 250 Newton. So this is 250 Newton. You put the value, you solve it, you will get the value of P as 625 Newton, the same value of P as the previous value. Previous value means when we considered both the bodies separately, when we draw their free body diagrams separately. Which one of them is simple and faster? Slightly faster, this approach. When we considered both the bodies as same, right? We considered them to be the part of a same body, right? But we are able to apply it smoothly without any problem, because both the bodies A and B here are not only trying to move in the same direction, but also are having same acceleration, moving as a single body, unlike previous examples. That is why we are easily able to do it. Always remember this. Do not randomly try to combine any two bodies. You may get incorrect answer in some problems. You got that? And let me tell you, this is also a very standard problem. A problem when you have two blocks over each other and you are applying force on the bottom one such that the slipping on the top box is prevented. It's a standard problem. There are some of the places where you can commit silly mistake. I have already told you that. Be careful in all those points.